5-9 is going to be based upon word problems. So the first thing we're going to do is give you all the formulas. If the keyword is compounded annually and your money is growing, then you're going to use the following formula. If it's compounded annually, but it says decay or appreciation, then you're going to use this formula. So I'm going to go ahead and write down what these variables stand for. The A is the ending amount. The P is the starting amount. R is the rate, but I want it written as a decimal. And then T is the time. Okay, if the keyword is quarterly, monthly, daily, or something to that effect, then you're going to use the following formula. And I already have the variables that I wrote down, except for this N. So the N stands for the number of times per year. So if it says quarterly, that means it's 4 times per year. If it's monthly, that's 12 times per year. And if you see the keyword is continuously, then you're going to use the formula PERT. A equals P E R T. R and T are exponents, E is the number E. Now, population is continuous. So if we have a population problem, then we're going to use PERT. All right, now we're ready to solve these problems. First thing you might want to do is find a keyword. So on number 7, the keyword is compounded annually, and it doesn't say anything about your money depreciating, so we're going to use the first one. And let's see, we do not know what the ending amount is because it says to find the balance after so many years, so I do not know what A is. The starting amount is 900. The rate, so my percent is a decimal, is 0.085 because I have to move it 2 places to the left, and then my time is 4. Since my variable is by itself, all I have to do is type this right into my calculator as I see it. So 900 times 1 plus 0.085, and then my exponent is 4. So my answer would be $1,247.27. And that makes sense because since my money's growing over time, I should have more money than what I started with. All right, the next one, the keyword I see here is compounded quarterly. So I'm going to have to use this one. So I'm going to write down that formula. Okay, so again, I'm not sure what the ending amount is, so I have to find it. So we start with $3,500. And then a CD, in case you're not sure what that means, it means a certificate of deposit. It's like a savings account. The rate is a decimal, is 0.054. Quarterly means 4, so 4 is going to go in for N there and up there. And then the years would be 5. Now, although my variable is already by itself, I don't really want to put this in all at once. That's a lot of stuff going on there. So what I want to do first is maybe figure out what this is. So I'm going to divide those two numbers. Okay, so I did that. And then I'm going to add 1 to it. So 1.0135 would be all of this. My exponent is 20. Bring this down. And now I can put all that in my calculator, exactly how we see it. So $4,576.60, which again makes sense because your money's growing over time. So your amount should be more than what you started with. Right. Let's move on to the next page. Okay, so let's see, I'm going to cross off some of these actually. I'm going to cross off number 10, and I'm going to cross off number 12. Okay, because I'm trying to do one of each type of problem. Alrighty, so the key word on this one is compounded annually, and it looks like my money is growing, so I'm going to use the first one. I only use the second one if it says something about depreciation. Alright, now this time I know what my ending amount is. I want to have a balance of $1,700. The question is, how much must you deposit? So this time I do not know what my starting amount is, but I know what my ending amount is. My rate as a decimal is 0.0725, and then my time is 3. This time the variable is not by itself, so I'm going to have to work backwards. What I probably want to do first is maybe combine this. Okay, so then maybe I should figure out what this is. So I'm going to put that in my calculator. Okay, and then what I want to do is this number right here is this. So I'm going to divide this number over to here. So I'm going to do 1,700 divided by the answer that I just got. To get the previous thing, you just do second negative, and that is my final answer. This is how much money you should deposit, which makes sense because it's smaller than what you end with. So we need to start off with $1,378.02. Okay, number 11, last one. Okay, the keyword here is compounded continuously. Since the keyword is continuously, I would like to use PERT. Okay, all I know is years and something about triple. It says my money is going to triple. So I'm not really sure how much I'm going to start with. So we're just going to pick a number. I don't know, let's pick 1. If I triple 1, I get 3. E is just a number. I do not know what the rate is, but I do know the time is 10. Okay, this problem is very similar to what we did yesterday on 5(8), because our variable is in our exponent. So what I need to do is divide over the 1, which is just 3. Maybe move the 10 and the r around. Now if I picked a different number like 2 and I tripled it, which is 6, if I divide 6 and 2, I'm still going to get 3. That's where that triple comes from. Anyway, So if I have a variable in my exponent, I have to put a natural log on both sides, because what that does is that allows my exponent to drop down to the front. And then the natural log of e, that's 1, so I can just make that go away. And then I have to get rid of the 10 by dividing the 10 over. So let's see, natural log of 3 divided by 10, I get 0.0109, but I want a rate, so that means I need a percent. So I gotta move my decimal this time 2 places to the right. So my percent is 10.9%. And that is lesson 5-9.